Secondary succession in Point Pleasant Park post-Hurricane Juan is completed by myself, Allie Chisholm, Connor Maloney, and Jordan Sampson.
Point Pleasant Park, Mnutukati, is a municipal park located in Halifax, Canada. In 2003, the park featured even-aged old-growth forest and is an extension of the Acadian forest biome. Since its formation, the park has been dominated by two species, red spruce, Pichia rubens, and red maple, Acer rubrum. Today, the park is open for recreational use. Mnutukati once served as a ceremonial site for the Mi'kmaq people, and now serves as a commemorative site holding many cultural artifacts. Now under municipal control, park management aims to protect sacred sites and incorporate Indigenous traditions. Hurricane Juan was a Category 2 hurricane which hit Nova Scotia September 29, 2003. With 145 km/h winds, Hurricane Juan decimated Nova Scotia and left devastating effects on Point Pleasant Park, killing 70% of the trees and forcing park closure for 8 months. The loss of trees in Point Pleasant Park was largely due to the even-aged nature of the forest. The majority of the trees growing were the same height, forming a canopy under which little else was growing. This left the trunks susceptible to high winds. Succession in Point Pleasant Park following Hurricane Juan aligns with patterns observed in long-term wind disturbance studies. Harmon and Pabst note that wind disturbances do not entirely reset ecosystems, but create functional changes over time. This recovery follows the process of secondary succession, which occurs in areas where an ecosystem has been disturbed but soil remains intact. To examine the effects of Hurricane Juan on forest secondary succession in Point Pleasant Park, this study employs a long-term ecological monitoring and comparative analysis. Various community metrics were calculated to assess how the forest has changed since the hurricane. This study answers three key research questions. How has the overall forest community changed over time? How has the chosen community metric changed over time? And how has the density of dominant species in 2004 and 2024 changed over time? To answer these questions, three null hypotheses were tested. These being, there is no significant relationship between time and overall forest density, there is no significant relationship between time and density of the red spruce and red maple, and there's no significant relationship in the Shannon Diversity Index over time.
Study the process of secondary succession in Point Pleasant Park. 5 areas with the greatest effect from the hurricane were chosen as study sites. These sites had seen the most destruction from the hurricane. Each study site was 20 meters by 20 meters in size. Within each site, the density of specific tree species were counted along with the diameter at breast height, or DBH for short. This is when the diameter of the tree is measured 4.5 feet off the ground. Using this standard measuring procedure makes industry comparison much easier, along with comparisons to other scientific studies. Retractable measuring tapes were used to create the 20 by 20 plots of land which were studied. 1 by 1 wooden frames were used to estimate cover percentage within the study site. Meter-long measuring tapes were used to measure the diameter of the trees for the DBH values as seen in the image shown. Data sheets were used to record the data, along with identification guides, which help students identify plants within their study site. Samples of unidentified plants were taken back in order to perform proper identification. One of the questions this study sought to answer was how the forest community has changed as a whole. To answer this question, the total density of the trees at 5 sites were recorded yearly with the exceptions of 2005, 2007, 2016, and 2020. In each site, the total number of trees were counted in order to obtain the density value. The forest community in Point Pleasant Park has seen a steady, gradual resurgence since Hurricane Juan in 2003, as seen in Figure 1. Figure 1 shows a 2,081% increase in density in 2024 compared to 2004. With an R-squared value of about 0.49, a 49% relation between time and density is shown. This trend aligns with succession theory, which predicts a progressive increase in density over the succession period. This rate of increase seen here is likely to slow down in the coming years as Point Pleasant Park reaches its climax community. Upon reaching the climax community, the density of species is expected to level out and remain at generally the same level.
To track secondary succession in Point Pleasant Park, 2 null hypotheses were tested. There is no significant relationship between time and density of the red maple between 2004 and 2024, and there is no significant relationship between time and density of the red spruce between 2004 and 2024. The alternate hypothesis to both being there is a significant relationship between time and density for each species between 2004 and 2024. To test the hypotheses, density measures were taken at 4 consistent sites, and density values were standardized to individuals per 400 meters squared. Over 20 years, red maple densities had many fluctuations, often reaching densities around 150 trees per 400 meters squared, then crashing to densities below 3 trees per 400 meters squared, as seen in Figure 2. The red maple often stabilized at densities of 40 trees per 400 meters squared. By 2024, the red maple density showed an increase of 1,400% from 2004. The regression analysis gave an R-squared value of 0.16 and a p-value of 0.0002. The p-value rejects the null hypothesis. The R-squared value indicates that only 16% of variation in density can be attributed to time. The red spruce density increased by 200% by 2024 from 2004, as seen in Figure 3. Compared to red maple rates, the red spruce increased in density at a more steady rate until 2024 and had a smaller overall increase. The regression analysis gave an R-squared of 0.12 and a p-value of 0.0009. The p-value allows for the rejection of the null hypothesis, and the R-squared value indicates only 12% of variation in red spruce density can be attributed to time. Fluctuations in red maple density, Figure 2, may be explained by self-thinning caused by an overshoot of carrying capacity. The density of red maples often stabilize at around 40 trees per 400 meters squared, indicating this as a carrying capacity. Therefore, as the forest reaches its climax community, the population of red maples is likely to remain at this density, as seen in 2023 and 2024. The red spruce were much slower to increase in density compared to the red maple and showed a lower increase, Figure 3. This is likely because of their different shade tolerances. Red spruce is a shade-tolerant species, while red maple is shade-intolerant. Red maples grow first because it prefers an open canopy with plenty of sunlight. Red spruce, however, can only begin to thrive once another species, in this case red maple, has established a canopy to block some of the sunlight. Both populations have relatively low R-squared values, indicating there are factors other than time affecting their density. This makes their future densities more difficult to predict. Since red maple thrives in an open canopy, if many disturbances continue in the park, it is expected that red maple will continue to thrive. As red maple creates a canopy, red spruce numbers are likely to increase following red maple. Without disturbances, red maple is likely to remain more stable, while red spruce will be able to increase. The observed patterns of recovery in Point Pleasant Park from 2004 to 2024 align with established models of secondary succession. The large increase in red maple density indicates it may be an early successional species, which develops the forest for late successional species, the red spruce. This shift follows the facilitation model, where early colonizers alter environmental conditions, allowing late successional species to establish.
The data collected was to observe secondary succession in Point Pleasant Park following Hurricane Juan in 2003. The intention was to observe a significant relationship in the Shannon Diversity Index over 20 years. The question was approached by collecting data in the same forest plots every year from 2004 to 2024. Specifically, density and size of each tree species were continuously collected. The data is shown in Figure 4. This includes a graph and linear regression analysis. The regression analysis gave a p-value of 2.2 times 10 to the negative 16, allowing us to reject the null hypothesis. Therefore, it can be determined that there is a significant relationship in the Shannon Diversity Index and time, and that the community in Point Pleasant Park is undergoing secondary succession. Shannon diversity in Point Pleasant Park displays an increasing trend among the species throughout the years of 2004 to 2024. This can be viewed as well by the positive slope of the regression equation, y is equal to 0.0606x minus 120.85, also seen in Figure 4. These results are post-Hurricane Juan, suggesting the forest is going through secondary succession. My QC statement for this question is the following. Shannon's diversity index of tree species, density, and size were measured in Point Pleasant Park following Hurricane Juan. There was an increase of 23% in the species from 2004 to 2024, indicating the community is going through secondary succession. Results to a study completed by Deror et al. In 2016, who observed tropical forests through successional processes, our results are very similar. They concluded that species richness increased with succession, showing a gradual accumulation of species, as well as Shannon Diversity Index. My prediction of what will happen to the Shannon Diversity Index as the forest moves towards its climax community is that this increase will begin to slow down as the community fully recovers. This is because the climax community describes a stable environment with a balance of species. Similarly, a study was conducted by Guaraguada and Ostertag in 2001, who observed woody plant species undergoing secondary forest succession in Colombia, Brazil, Venezuela, Puerto Rico, and Panama. Their results confirmed species richness and Shannon diversity index increased rapidly during the first years, but that within no more than a few decades reached values comparable to before destruction. In conclusion, there was a significant relationship between total density of overall forest community over years. There was no significant relationship between time and density for the red maple. There was a significant relationship between time and density for the red spruce, and there was a significant relationship between Shannon diversity index over the years. Based on these trends in the data, Point Pleasant Park is undergoing secondary succession. We believe the Acadian forest in Point Pleasant Park is in mid-succession stage, as there has been no data stating any slowing of the increase involved in total density, and Shannon diversity indexes over the years of 2004 to 2024. This also indicates the community has yet to climax. Two examples of how being an urban park can affect succession includes human disturbances and maintenance of the park itself. Looking at Figure 4, the Shannon Diversity Index has some variability and increase. While the overall result is a significant increase, human disturbances such as going off trail sites, littering, or any sort of destruction to the species can cause variability in the Shannon Diversity Index data. The variability in Figure 4 indicates potential human disturbances that would have affected the succession process. Similarly, maintenance of the park itself ensures the health of all species in the forest. Therefore, looking at Figures 2 and 3 indicates the park was well maintained, as the density has a significant increase. Overall, ensuring the forest is well maintained and that human disturbance does not occur, the succession process can be successful. Rico and Hastad in 2022 highlight that an important element to Indigenous is natural resources. I think that being more mindful of the resources around us is important for assisting Point Pleasant Park's recovery to a mature Acadian forest. Being aware that humans have an impact on forest succession is a good start, but overall, ensuring not to cause disturbances such as littering or going off trails in urban parks will ensure the succession is successful.
We would like to thank Dr. Allison Schmidt for her instruction, as well as Vanessa Landry for her support. Additionally, we acknowledge the contributions of previous BIOL 2060 students and Christine Beauchamp, whose work provided the data for this research. Finally, we would like to thank Dalhousie University for providing the resources and facilities necessary to complete this research.
These are our references.